So till now we have worked with various operators, but to work and the operators basically work on variables, right? So the variables need to be of certain data type. That is, what is the type of number or value that that the variable can store is decided by what type of data type is that variable. So Python supports majorly four different types of data types. So just quickly have a look at them. So you have numbers. Under numbers, you can have an integer, which can be any non-decimal number, positive or negative, both are supported. You have floating point number, which can be any decimal number. Then you have complex number, that is 1 plus 2j is as an example here. Any complex number can be represented in this complex format. So these are the different types of numbers that are supported in Python. Then you have a data type called as Boolean. So the variable which is a Boolean can be either true or false. Please note this is the case of true or false. So if I say x is a Boolean, x can have the value equal to this true, right? That's the expected value. If you say x is Boolean, it is supposed to be either true or the false value. Then you have a string variable. String data type basically is denoted by a double quotes. So any value that are put inside double quotes become a string. So if I say x is equal to anything within double quotes, I can put any value. This whole thing becomes a string, and that is assigned to the variable x. So x becomes a string data type. There's a special data type called as none. None is when you have not assigned any value to the variable. So neither is it a number, nor is it a boolean, nor is it a string. It doesn't fall under any of these categories because maybe you don't know what type of data is going to come into the variable. So you have just created a variable but not assigned any value to it. So there is no data type assigned to the variable. So it's a none type data type. Fine. So let's just quickly look at all of these as an examples. So if I say x is an integer, I can have any value x as 10. You can find out the type of variable by using the type function. So if I say type of x, it returns me class int. So the variable x was given a value 10, which is a type of integer. Right? So x can be a floating point number, 10.5 let's say, and I say type of x. X is a type of floating point number. Right? Now, instead of that, if you want to give it a boolean number, I can x can be true. So now a type of x is boolean. Uh, See, please note that if you the moment you change x value to anything else, if I say x is equal to 1, it becomes an integer. So uh, even though most languages would treat a value, for example, C would treat 0 as false and 1 as true, because we have a dedicated Boolean data type here, you're supposed to use this value for Boolean operations, right? So x true or x can be false. Now note the syntax, you can't, I mean the case of it, you can't have a different case. It has to be capital first letter, everything else is small. So x false, this is not recognized. All capital if you try to use, it does not know what this is. So false is not defined. Fine. So the case is important. So even for true, it has to be capital T and everything else is small. If you try to change it, it will not know what it means. Alright. So that is the different types of data types. If you want to have a complex data type, like you can have x is equal to 10 plus 5j, and you can look at the type of data type of x. It's a complex data type. Right? Now, sometimes once you have created a variable, you might want to convert it to a different variable. Now, let's say I have created x equal to 10.5 as a floating point number, but now I don't want x to be floating point. I want to use x as an integer. Right? So you can typecast variables or type convert variables from one format to other. So the functions are like this. So if you use the function int, so if you look at this function int, any number given to it is converted to an integer. So if I say int of x, now x as of now, if you look at it, is floating point. If I say int of x and let's say assign it to y, and let's see what y is now. So you can see y becomes 10 and the decimal uh, value after the decimal point has been removed. And if you look at the type of y, it is integer. So x was a floating point number. We converted the type from floating point to integer by saying using the function int. So saying convert to int. What do you want to convert to int? The value x. Alright, so x becomes converted to int. Now you have to be careful. It does not mean you can convert anything to int. So let's say I give x is equal to some string. This will not work. Okay, so you can't convert a string to an integer. Right? So it has to be some form, some number. So just because the type conversion is available does not mean you can convert anything to anything that you want. So it has to be a valid conversion. So there is no integer representation possible for hello, right? So it can't convert it to integer, right? So similarly, I can convert something to floating point. Let's say I have a value of x is equal to 20 and I want to use it as a floating point number. I can say float of x. So it becomes 20.0. Right, so if you can assign it to a variable if you want, float of x. So if you look at the type of y now, it becomes class float, right? So type conversion is possible again only if it is supported. So x should be, it should be possible to convert x to float. So again, if you use some integer value to convert to float, it will again throw an error. So if I say float of x which is an integer, it doesn't work. Can could not convert string to float. Doesn't make sense, right? So then you have to convert to string. So any number which you have, so if I have x is equal to 30 as a number and I want to use this number as a string in future instead of integer, I can say string of x. The value does not change, the data type becomes a string data type now. So if I say y is equal to str of x and I look at type of y, you can see it has become string. So even though x was integer before, the value of y is still 30, but it is in quotes now. So if you look at x, x is 30 without any quotation marks. That means it's an integer x. Y is a 30 with these two quotation marks around it. It means x y value is 30, but it's a string, not an integer value. So you can't do mathematical operations on this, but you can do mathematical operation on this, which is an integer. So similarly, you can convert string anything. So if I have a floating point number 30.5 and I say str of x, that becomes a floating point number, right? So the value still remains the same, only the representation becomes a string representation. Then you have chr. So it converts the given ASCII number into its equivalent character representation. So if I let's say if I say 85, 85's ASCII value, well, 85 represents in ASCII the character U, right? So it returns the character equivalent of this number. So the expectation for input to CHR is some number which is an ASCII code. So equivalent ASCII character from this code is returned as a value, and this is a string return. So if I look at x is equal to CHR of 85 and I say what is that, sorry, CHR of 85, and I say what is the type of x, it gives me string. Okay, and what is the value of x? It is the ASCII equivalent of capital U, which is 85. So 85 in ASCII code is nothing but the letter U. Right? So you can use pass any number here Let me take some any random number. I don't know what 40 represents in ASCII. 40 represents an open bracket. Right? So whatever equivalent for ASCII code is there, that is returned as a value here. Right? Then you have complex. So I can generate complex numbers using the complex type conversion. So all you have to do complex 4 comma 5. So it becomes 4 plus 5j. 4 is the real number, 5 is the imaginary number. We can also pass integers a floating point to this. So you can say 4.0 comma 5.0 or point 0.3, let's say. You can also pass string variables, but the limitation is only the first variable can be a string. You can't have anything else after this. So there is, you can't pass another variable after giving a string. If I say something else, it doesn't take, can't take a second argument if the first is a string. So you can pass a string variable, but by default this is taken as the real value and imaginary is made as 0. Alright. So while passing integer, if you don't pass the imaginary value, it automatically takes as 0. Alright. So that is how you create complex numbers or convert int or float into complex numbers. ORD is a function which is used to find out the Unicode of a given character. Okay, so if I say ORD of R, the Unicode representation of R is 114. Okay? So it returns back the Unicode of any character you pass. So again, it is expectation is you pass a character. I can't pass a number here because in Unicode everything is a character, and that is converted to a equivalent code representation. Unicode is something like a encoding format. Mm, For now, that is enough. You don't have to worry too much about how Unicode works. But remember, ORD is a function from which you can find out the Unicode value of any character. Hex returns the hexadecimal equivalent of a number. So if I say hexadecimal of 255, it gives me FF. But this is a string. Alright, so if I say x is equal to hex of 255 and I say type of x, it is a string value. So it only gives you the value in hexadecimal, but actually it is a type of string, the return value. Okay, so any number you want to find out the hexadecimal, you can do it. You can say 34. What is in hexadecimal? It is 2b, right? So converts the given value into, but again the conversion has to be logically correct. You can't pass something like a string and ask it to convert to hexadecimal. Doesn't work. Alright, so you have to be a little careful on what you pass as for conversion. You can't plot floating point number and convert to string, convert to hex, because hex basically is all are integers. Alright, so you can convert only integer numbers into hexadecimal. Alright, so that is your hex. Similarly, you can convert a given number into octal. So if I pass any number to it, the octal equivalent is returned. You can see it is a small o is prefixed with the number. Right, so this indicates octal. So here x indicates hexadecimal, here o indicates octal. So 0x, 0x because you can't start a number with a alphabet, so you're putting a 0, x indication of hexadecimal followed by the hexadecimal number. Here again 0, o indicative of octal number and pass followed by the number itself. So OCT will give you octal equivalent of any number you want to find out. So that is with respect to data types and converting from one data type to another data type. Right. So that clears the usage of data types in Python. Thank you.